NumPy is very much useful in the concept of data science, or in the concept of you can see the data processing and all. Okay, so let's talk about the NumPy today, and in the next class we'll see the pandas. What do you mean by pandas library? So the NumPy is nothing but the general purpose array processing package. So if we have any type of array in n dimension, so n dimension means it may be more than one, right? So if we have an array of one dimension, so we know whether it will be a column array or row array, or you can say column matrix or row matrix, right? But if we'll talk about NumPy, so NumPy supports the array of n dimension. It provides a high performance multi-dimension array object and tools for working with these arrays. And there are different, you can see there are different tools that are also useful here, by which we can do different type of operations on array. So this particular package is a fundamental package for scientific computing in Python. It contains various features, including a powerful n-dimension array object, sophisticated broadcasting function, tool for integrating C++ Fortran code, and useful linear algebra, Fourier transform, and random number capabilities. So NumPy has a vast features that will be used in the research of data science and data processing. And but here in this particular course, we'll see about the first one, which is the first feature of the NumPy, which is the powerful n-dimension array object. And we'll consider it as a n-dimension array object here, and we'll try to find out different functions, different ways to handle the n-dimension array. Besides its obvious scientific use, NumPy can also be used as an efficient multi-dimension container for generic data. So if we have different type of data available, so that data could be arranged in the form of n-dimension array. And you know that what do you mean by an array, or what do you mean by, so we can consider a table or a data set of two dimension, right, where we have the columns, and columns are called features, and then data inside it. So in any of the data set, or any of the data can be processed in the data science. So for that, NumPy is very much useful. Attribute data type can be defined using NumPy, which allow NumPy to seamlessly and speedily integrate with a wide variety of databases. So because we can use different type of databases into the array, or into the data that we'll put into the array. So this particular NumPy feature is very much useful to integrate with various databases, or we can extract the data from various databases, and then we can do the processing, and then again we can store the data into those databases. So all these things can be done using NumPy. So to install NumPy, what we have to do, we have to write the command with the pip install NumPy. It will install this particular package. So this is the way how we can install the package of NumPy. Let's talk about NumPy and we'll see how it works. So as I told you, this NumPy, will consider it as here as an n-dimension array. So whatever object that we'll create as an array object. So we can do many things. We can create the array, we can index the array, we can extract the data from the array, depend upon our requirement. let's see how we can use the NumPy. So to using the NumPy, the first thing that we have to do is to import NumPy. Okay. So once the package will be installed, the library package will be installed of the NumPy. We'll just import the NumPy by writing import NumPy as NP. As why we have written NP instead of writing NumPy all the time, I'll write NP instead of that. Okay. Now this NumPy is nothing but taking as an object, and you know that if any function or any method or any method or function is dedicated for the object, then we have to call the function using dot operator, and generally these functions are called method. So here this NumPy object has different methods that we'll see one by one. So first is to create an array. How we'll create the array in the NumPy? So we have to use np.array function. Array function is inside the array function. We can use list, we can use tuple, we can use dictionary. So any of the object we can take. It means we can create the array using NumPy with basic object. Either we'll take the object of list or we'll take the object of tuple or any other objects. Now here in this particular code, we have created an object called ARR. So ARR is nothing but it is holding this object. So what is this? This is nothing but a NumPy object, and this NumPy object is created with two different lists. This is one list and this is another list. So one list it will take as a one row, another list it will take as another row. So we have two rows here. You can see it will make a two-dimension array here. Now, what is the type of this particular array? It is going to print. It is going to print. What is the type of that array object? It is a NumPy object, right? So it is going to print NumPy there. Now, after that, we can have many other method that we can use here. It is not the method. You can see here it is just the what we can say, it is just an instruction that will be useful here. Now here array.ndem will give you the dimension of the array. Array.shape will give you the shape of the array. What is the shape of the array right now? Array.size will give you the size of the array. It means how many elements are there in the array. It will just find it out how many elements are there and it will print it. And then array.datatype will give you the data type of the value in that particular array. So what is the value inside the array? It will give you the data type of that particular value. So you can see what we have done. We have first created an array using the list. Is a very simple way of creating an array. This array is of two-dimension array because we have used two lists here. If we'll use one list, it will become one-dimension array. Because we have taken two lists, it will become two-dimension array of two rows and three columns. As you can see here, we have three columns and here we have two rows. So 2 into 3 will be the dimension of this particular array. Now what is the first print is going to print is the type of the array object. So what is the type of the array object? It is of type NumPy, and we are creating the n dimension array, nd array. Okay. Now what is number of dimension here is because this dim will give you the number of dimension here, so it is of two dimension array. So ndim will give you 2 as the output. Then what is the shape? Shape we have 2 into 2 cross 3, right? So 2 row 3 column. So shape will give you 2 comma 3 as 2 rows and 3 columns. Now array dot size, it will give you how many elements are there in that particular array. So if we have 2 into 3 dimension shape of the array, so definitely it will give me 6 elements. So 6 element will be there. And what is the type of the data inside the array? It is of because we have used integer here, so it is giving you integer as the data type of the element. So you understood this, all these things. So what we have the object. What is the object that we have created? We have created a n dimension array of NumPy object. What is the dimension? It is of 2 dimension. What is the array size, array shape? So we have 2 into 2 cross 3. How many elements are there? So it will be 6. And what is the data type of the value which we are using inside the array? It will be integer.
Excuse me, sir.
Yes.
Sir, it stores elements of type int. Then what is that 64 written? Int 64. What does it exactly mean?
Yeah, it is of see, the array data type is int, but 64, 32, in that way it used to give like of 62 bits or 32 bits. What type of I think it is depend upon what type of uh, I think it depend upon the maybe the operating system or something. Let me clear. 64-bit integer, it says that 64 refers to the memory allocation to store data in each cell, which effectively related to how many digits it can store in each cell. So so here from NumPy and the pandas onwards, we are dealing with the data sciences. Okay, so everything will be different there as traditional Python that we have seen. Now here it will be either int 32 or it will be either int 64. So it may be of 64-bit integer we have taken here, which stands for 64-bit integer. It is an integer, but it is of size 64-bit. So it will be either 32 or 64. Here also in pandas and NumPy, you will find out by default it is in 64 or float 64 in that way. Okay, so here we have different data type that also we can add, like float 32 in that way. Instead of only float, we can write float 32 or float 64, int 32 or int 64. In that way we can write and explicitly define the data type of it. So it is int 16. So 16 is also taken here in a NumPy. Okay, so here it is about all those things. So if we have int 8, so this is the size that they can take it. If we have int 16, so this is the type of site of this the range of the integer that it can take it. We have int 64, this is the size of the integer that it can take. So I think now it is clear. So these many integer digit it can take. It will be very useful in different way of using the Python. What happen is, let's say, if we are making a project on some security. So what happened in the security? We use some encryption decryption algorithm. So in the encryption decryption algorithm, will use some sort of keys. So right now the size of the key is very large. So the size of the key is, let's say, 64-bit or 128-bit or 256-bit of key size. So I think this will be very helpful for those keys value to be accommodated. That facility was not there previously in mm, different languages, like in C or C++ or other languages. We have restricted integer dimension that will be there. So the meaning of int64 is these much of the range of the integer, and for 32 these much of the range of the integer that can be accommodated. So int 8 is this much of integer could be accommodated. So this is how it will be done. So that's why over there it is int 64. Okay, so about the int 64, we know this is the by default value it is taking. In the later of the portion, you'll find out that we'll define the data type also. Whatever the value that we can take inside the array, that also we can define it. So in the array creation, we have seen how we have created the array with the help of the list. You can create an array from the regular Python list or the tuple using the array function. So we have to use array function like this to create an dimension array. Inside that, either you can take a list or a tuple, either or a dictionary also you can take it. The type of resulting array is deduced from the type of the element of the sequence. So whatever the type of the element that you will give, so that type actually it will show here with this particular command. Often the element of an array are originally unknown, but its size is known. So whatever size that we are putting it, it is actually known to us. Hence, NumPy offers several functions to create array with initial placeholder content. These minimize the necessity of growing array, an expensive operation. Now here we'll see some of the functions related to creating an array of, let's say, the default array, how we can make the default array, all those things. So we have some example like np.0 or np.ones or np.full or np.empty, all those things we'll see in this particular example. We have some more functions that we'll use here. We have arrange function, we have line space function, we have a reshaping array function, and we have flatten array function. So all those functions we'll see one by one. So what do you mean by arrange function? So arrange function is nothing but it will create a array with some sort of initial value, final value, and the steps. Just like your once you have created with the help of the range function, right? So just like the range function to creating an array, we have the arrange function. Then we have line space. What line space will do is it will also create the array with the different elements. But the thing is that here we have the initial value and the final value. And in between we can put some values. Here we doesn't have to put the interval. The interval will be taken as a by default value. So we'll see that particular one, then you can understand. Then we have a reshaping array function. What will happen is in that particular, we can reshape the array. whatever shaped array we have, let's say we have 4 cross 3, or let's say we have 8 cross 4 array, we can actually reshape that particular array into different dimension of array. If we have 2-dimension array, we can make it 3-dimension array with the help of 2-dimension. Then we have flatten array option. In that way, what will happen, if we have the array, we can, of any dimension, we can convert it into 1-dimension array, so that we can use. Okay, by default, how we can use it, row wise we can flatten the array. If you want to use column wise, then F you have to use, otherwise C is the by default version of that function to flatten it. Let's see one by one. So first of all, when we want to use NumPy, we have to import NumPy, and as we are doing NP, so instead of writing NumPy all the time, I'll write NP. Now here we have created an array with the help of 2 integers, and we have defined the data type here. See, what is the data type here? It is of float. I can write 32 also. Is there any problem in that? There will be no problem in writing float 32. Can I write 64? Yeah, 64 is also been taken here. So the default value of float, I think this is the standard of float. So default value is 64. You can use 1632, and then 64 is there. And then there is some more data type that you don't know till now, is complex data type. That also we'll see here. So the complex number we can write here. We can use here. Okay, come to our array. So we have created an array with two list. So what is the size? Size is 2 comma 3, right? So 2 list, it will go in one row, and in each list we have 3 values, so it will become 3 columns of my array. When I print the array, it will print 2 cross 3 array. Now creating array from tuple, we can also create the array with the tuple. So you know that how we can define a tuple, right? This is the way how we can define a tuple. And using this tuple, we can create an array. So this will give me 1-dimension array. Okay, so please take care of your status, whether it is a mute or unmute. Okay, come to np.0. What it will do is it will create the whatever dimension that you have suggested, and it will create with an initial value of 0. So it will create 3 cross 4 array of value with all zeros. Then we have np.full. So here what will happen is we'll create 3 cross 3 dimension of array with all value as 6. And the data type here, what we are taking here, we are taking complex data type. So it will create all value as 6 into 3 cross 3 array, is a 2-dimension array of complex type. Okay. Now, if you want to put some random value there, so you can use this particular function random.random, and then in that you can give the dimension. So here we have 2 into 2 cross true, and the random value will be from 0 to 1. So whatever value from 0 to 1 will be taken as random value and will be created 2 cross true matrix here. Now arrange So as I told you, it is just like a range. In the range, what we use is we'll use the initial value, we'll use the final value. Actually, the final value will not be taken care. It will take up to 29, okay? And it will take 5 steps at a time. So first it will print 0 and then 5 and then 10, then 15, then 20, then 25, and then 30 it will not be included, just like a range. Now we have line space. What it will do is it will go from 0 to 5, including 0 and 5, and it will put 10 random values inside 0 to 5. That is line space. So it will, this 10 is not the step, okay? This is the random value up to this. So we need actually 10 values, and we know what is the initial value, what is the final value. So how many values are left? Around 8 values are left. So it will pick up 8 value randomly and put it into the in between 0 to 5. Then in this we have created array of 3 cross 4, 3 rows and 4 columns with the help of 3 different different list of 4 elements in all list. And then we'll use the reshape function. In that we'll create 2 cross 3 array. It means it will be 3-dimension array we can create with 3 into 4-dimension array. So we can reshape it. Okay, and then here again one array has been created with 2-dimension array, 2 rows and 3 columns, and we'll use the flatten function to flatten it. Flatten it means it will be a 2-dimension array, but it will look like 1-dimension array by using flatten keyword. So let's go one by one. So what is the first printout that we have taken is, we just print out whatever the value of A. So whatever is the value of A is 2, 3, 4, 5, 8, 7. It will be a 2-dimension array, right? So it will be 1, 2, 4 and 5, 8, 7 of 2-dimension array. You can see here we have dots. Why it is dots? Because the data type that we have used here is the float type of data type. That's why it is coming and dots there. Now let's come to another array that we have created using tuple. So it is just a 1-dimension that we have created. So it will come as a 1-dimension array here. Now the third output is we have used 0 function, right? 0 function in which we have created 3 into 4 array, n-dimension array of all value as 0. So here also we have 3 cross 4 with all value as 0. Now come to another function called full. Here we have 3 cross 3 array, all element as 6, but the data type here is complex. So you see how it look like. So we have all value as 6. Also here all real value is 6. All real value is 6. But the imaginary value is, because we haven't given the imaginary value, it is of complex type. Then random value we have created of 2 cross 2. It will be the random range is 0 to 1. So whatever the value that you can take from 0 to 1, it will be taken as a random value and put it into the 2 cross 2 array. Now after that we have a range. We have created an array with the help of a range from 0 to 30. So it will be it is creating 1-dimension array. And what is the value here? Value, it will start from 0, go up to 29, and the step is 5. So let's start with 0, go up to 29, and the step is 5. So you can see up to 25 it is going to print. Now the same thing is happening with the help of line space. In the line space, as I told you, it will pick up the value from in between 0 and 5. All the 8, we require 10 values. So 0 and 5 are the 2, I think. Another 8 value will be chosen here. So this is the initial value. This is the final value. And the in between value has been chosen. So this is 1, 2, 3, 4, 5. 6, 7, 8. So as I told you, 8 value will be chosen here in between 0 and 5. Let's go to another function which is called reshape function. So initially we have taken array of 3 cross 4, and the reshape function will create 2 into 2 into 3 dimension, 2 into 3 into 2 into 2 into 3 shape of array. So you can see this is the original array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then when we'll reshape it, it will create 2 array. So this is 1 array. This is another array of 2 cross 3. So this is of 2 rows and 3 columns. Here also it is of 2 rows and 3 columns. Now the last one is flatten. In that we have created an array of 2 cross 3, and this flatten will just flat it and will create a 1-dimension array. So you can see here, this is the original array of 2 cross 3, and when we use flatten array, it will just make it a flat. So it is a row wise, it is going to read. So 1, 2, 3, and then 4, 5, 6 in that. Can we use F there? So how it will take the So here you can say when I'll use F, it is taking a column wise. So it is taking 1, 4 first, and then 2, 5, and then 3, 6. 1, 4, 2, 5, 3, 6. In that way, it is flattening the array. By default, it is of row wise taking it, but you can take it column wise also by putting here the parameter F or the parameter C. C is to take row wise and F is to take column wise. So this is how it will do flattening your array into 1-dimension array. Now let's go to the indexing of the array. So how we can do the indexing in the array? We know how we can do the indexing. We know in the basic object like list or tuple or dictionary, how we can do the indexing. In the same way, we'll see here how we can do the indexing. So we have different way. We can do the slicing just like the list, or we can use integer array indexing, or we can use boolean array indexing. Let's see one by one what are those things. So let's see, if we have created an array with the help of NumPy, we have to import NumPy package first. We have created an array. So here the array is created with the help of 4 different lists of 4 element each. So it is a 4 cross 4 array. Now we are doing slicing here. So this first parameter will tell you that how many rows we are taking. So we are taking the rows from 0 to 1 because the value is 2, right? We know what do you mean by this. So it will take this 0th row and first row. Getting it? Now the second one is from this 0th row and first row, means from these highlighted value, it will take all the values, but it is just going to print alternate one, means with a two-step. So what will be the output? The output will be, it will just print -1 first and then 0, and then it will print 4 and then 6. So this will be the output of this particular slicing. So I think you understood the meaning of this slicing. The first one will tell me how many rows I have to use, and second one will tell me that this highlighted version is telling me from this 2 rows I can take all the elements, but I'll use a step as 2 step at a time. So the output is -1, because 2 step is not 1 step. So next is 0, then 4, and then 6. So you can see here -1, 0, 4, and 6 will be the output. Let's say this is the array, right? Now we can do with the help of integer indexing also. This is the integer indexing. What is that? Here we have made the indexing like 0th row, first, third column is the indexing, right? First row, second column, second row, first column, third row, 0th column. In that way it is going to print. So what is that? 0th row, third column. So what is in the 0th row? This is the 0th row. What is in the third? So it will be 0, 1, 2, 3. So it is going to print 4. Getting it? Now the second one is first row, second column. So first row is this is 0th row, this is the first row and second column. So it will be 0, 1, and 2. So it is going to print 6. So the first value is 4, second value is 6. What is the third value that we'll get here? Second row, first column. So this is my second row, and the first column, this is a 0th one, and this is the first one. So right now it will print 4, 6, and 0. And what is the last one? Third row and 0th one. So it will be 3. So 4, 6, 0, 3 will be the output. See here, 4, 6, 0, 3 will be the output for that. Okay, now we can do the indexing with some Boolean array indexing by using some conditions. So this is the condition we have. What is the condition? The condition is array. What is the array? Array is the object. So we'll take the value which is greater than 0. So we'll just take the value in this particular array which is greater than 0. So array and the condition when we'll apply, so we'll get all the values which are greater than 0. You can see here all the value will be printed which is greater than 0. So these are the 3 type of slicing that we can do. The first is, we know what we mean by we do the indexing with 3 type. First is the slicing, second is the integer value slicing, and the last one is your Boolean array. So we have created for that we have created a condition, and the condition will be used here, and based on the condition only we'll get the output. So this is the way how we can do indexing, the 3 ways to do indexing. Okay. Okay, right now the time is 1:10. All of you go to the Google Meet and go and log in there. Now let's see another basic operation. So the large amount of built-in arithmetic functions are there, as well as there are some overloaded arithmetic operation that we can use here in the array. So we have an array. This is just the one dimension array that we have created. In this we can do like this. We can have this value a, right? So a is an array. So a plus 1, when we do, what will happen is it will add 1 to every element. So what is the value that we'll get is 2, 3, 6, and 4. This is the value that we'll get. 2, 6, 3, and 4. Now what about this a minus 3? It is just take all the element and it will do -3 on that. The first one will become -2, -1, 2 and 0. -2, -1, 2 and 0. In the same way, we can do the multiplication also. So a into 10, it will just multiply. So 1, it will multiply with 1, multiply with 2, 5 and 3. In that way, it is going to print. We can do the squaring also. A to the power of 2 also we can do. So 1 to the power of 2, 2 to the power of 2, 5 to the power of 2 and 3 to the power of 2. So this is the output for that. 1 to the power of 2, 2 to the power of 2, 5 to the power of 2 and 3 to the power of 2. Also we can modify the array itself. So if we'll do a equal to a into 2, so it will multiply 2 in each element of the array, and then it will modify the actual or the original array also. So the original array has been modified. This is the original array. We have 1, 2, 5 and 3, and after this operation, the array look like 2, 4, 10 and 6. We can do transpose also. If we have this array, we have 2-dimension array of size 3 cross 3, so it will do transpose also. So this is your original array, and when we do the transpose, it will do the transpose array. So for that, we used to have a dot t. It will just transpose your array. Okay. We have some unary operation also. We have some binary operation also related to the NumPy. So unary and binary operation we'll see into the next class. And if you have some more questions related to NumPy, that also I'll take into the next class.